A warm welcome to the 21st session of the 4th module of Signals and Systems. In the previous session, we have been looking at the differentiation property of the Z transform, and we have been looking at rational Z transforms in some detail. In this session, we will continue with that discussion. So, we will look at rational Z transforms where we have repeated factors now. So, let us take an example first. Let us consider, for example, the Z transform H of Z is 1 by 1 minus half Z inverse squared into 1 minus 1/3 Z inverse with mod Z greater than both of them, that is mod Z greater than half and mod Z greater than 1/3, which means mod Z needs to be greater than half, which becomes the region of convergence. Now, the question is to find the inverse Z transform of this expression with its region of convergence. How do we go about it? So, the first thing is to decompose into partial fractions. And how would the partial fractions for this expression look? Hz would be of the form sum A1 divided by 1 minus half Z inverse. So, this is the form we want. We want each factor to be explicit in all its powers. So, for example, you will see here that the repeated factor occurs with all its powers, a power of 1 and a power of 2. So, of course, now if you wish to make a partial fraction decomposition, we must equate this. So, you equate it to 1 by 1 minus half Z inverse squared into 1 minus 1/3 Z inverse, and let us find the easier ones first. So, we can find A21. How do we find A21? We will multiply both sides by 1 minus half Z inverse the whole squared and then put Z equal to half. So, that can be done. Let us do that. You will of course get 1 divided by 1 minus 1/3 and Z is half, so that will Z inverse would be 2. So, 1 minus 2/3, that makes it 1/3 in the denominator, and therefore, A21 is equal to 3. Similarly, we can find A2, and I will show you the working in green here. A2 can be found by multiplying both sides by 1 minus 1/3 Z inverse, then putting Z equal to 1/3. So, we can do that. Multiply both sides by 1 minus 1/3 Z inverse and then put Z equal to 1/3. That leaves you with 1 minus 1 by 1 minus half into Z is 1/3. So, Z inverse is 3. So, you have this squared 1 minus 3 by 2 the whole squared, and that is minus half squared. So, that is 1/4 in the denominator. So, A2 becomes equal to 4. And now there are different ways of finding A11 once you have done this. So, let us put down these two first. We have Hz here is already we have calculated most of it, A11 minus divided by 1 minus half Z inverse, plus we have calculated A21 to be 3 and A2 to be 4. Now, one easy way to find A11 here, simply subtract. So, you can do a subtraction 1 by 1 minus half Z inverse minus these two terms. And here when we subtract, we should see, so in fact the exercise which I am going to give you is to complete this working. Now, there is another way in which you can find A11. Let us explain that too. And this is more general. So, we have Hz is of this form. We can multiply both sides by 1 minus half Z inverse squared. Now, we can differentiate both sides with respect to Z, or rather with respect to Z inverse. So, treat Z inverse as a variable here. And now, what we do essentially, see when you do that, A21 disappears and dz inverse of 1 minus half Z inverse into A11 is minus half A11. And then of course here when we differentiate this with respect to Z inverse, it would still retain the 1 minus half Z inverse factor. So now when we put Z inverse or rather 1 minus Z inverse equal to 0, we would get minus half A11 is essentially d d Z inverse into 1 minus half Z inverse h z, all this evaluated with 1 minus half Z inverse equal to 0 or Z equal to half or Z inverse equal to 2. So, we can find A1. Now, the exercise for you is also to verify that you get the same answer. In fact, this method is more general, because if you have a higher power of the factor 1 minus half Z inverse, for example, suppose you had 1 minus half Z inverse to the power 3, for example. Let me show you just the important steps. So, suppose we had you had a third power of 1 minus half Z inverse in denominator, then of course you recognize that this would have 3 terms. It would have the term of the form A11 by 1 minus Z inverse plus A21 plus A31 and then other terms. Now again we can multiply both sides with 1 minus half Z inverse cubed. So, if I multiply both sides, here I multiply this by 1 minus half Z inverse cubed, then of course this leaves just A31 here, this leaves you with A21 into 1 minus half Z inverse, and this leaves you with A11 into 1 minus half Z inverse the whole squared. And now we can successively differentiate. When you successively differentiate, you would get the terms one by one. So, for example, without any differentiation you get A31, with the first differentiation you would get A21, and with the second differentiation you would get A11. So, that is how we could proceed. Anyway, this was meant to illustrate how we could make a partial fraction decomposition. I am just reviewing these ideas because you need to use them again and again. Now, having done that, what is the next step? The next step is to apply the differentiation property again and again. So, for example, you know how to deal with 1 by 1 minus half. Let us do that. We know how to deal. Now, if you differentiate this with respect to z, you would get of course minus 2, and this becomes a power of 3 in the denominator, and then minus half, there you are. So, now I take minus z times d dz. So, here of course there is a minus 1 here too. So, it would be 2 times half times z to the power minus 1, because you are multiplying by minus z. So, there are 4 negative signs, and 1 minus half z inverse the whole cube. Now, this would correspond this overall operation here. So, this minus z d dz would correspond to multiplication by n, and therefore, you could now reason out what happens when you have just 1 by 1 minus half z inverse cube. There is a z inverse factor here which you have to take care of. If you do not want the z inverse factor, you need to advance the sequence by 1. So, essentially you are multiplying by z. So, you are advancing the sequence by 1. It is a shift, is not it? We have seen that before. If you shift a sequence, then it amounts to multiplying the z transform by a power of z, an appropriate power of z, integer power of z. Anyway, this was to review how we could invert a rational z transform. So, now we have all the tools. In fact, we were already experienced in inverting a rational Laplace transform. We have now seen how to invert a rational z transform. I shall say a little more about rational z transforms in the next session. Thank you.